Good evening. Thank you so much for joining us and for coming out. We're from Southern California, and we noticed that the temperature dropped below 70 degrees in LA. No one would leave their house, so it's really cold out. Thanks for bearing the weather. We want to give a big thank you to Jan 11, Pioneer Works, Andrea Lauer for making this fantastic bandana. We couldn't think of a better venue that could celebrate this intersection and collaboration of art and science.
Before we sit down with Jana to have a really interesting discussion, we'll read to you some of the verse from the prologue of our book, accompanied by paintings of Lia's, which explain what the book is all about. So that's the whole point of this initial reading and of the book's prologue. Our universe is varied and vast. Galaxies, planets, stars, and moons, quasars, pulsars, and magnetars, all made from atoms and molecules, just like you and me, and all that we hear and touch and see. Our universe is also endowed with a marvelous shadowy side that is warped, phenomena forged from warped space-time. Witness the ravenous fat black hole that Lia here depicts ingesting her wife, Felicia. Felicia's in the audience. I'm sorry, Felicia.
Although this warp side is entwined in the weft of our matter-filled universe, its stars, its planets and nebula, its galaxies and its comets, we humans never saw it until just recently. Why did we never see? Warp space-time cannot produce light or other signals that yesterday's technology was able to perceive. So now, how has that changed?
A very long time ago, 1 billion years in the past, while here on Earth, multicelled life arose and spread around the globe. But in a galaxy far, far away, two spinning black holes danced round one another, rippling the fabric of space and time. The ripples, we call them gravity waves, sucked energy from the hole's orbit, so the holes spiraled inward, eclipsing each other toward a climactic collision. The holes at half of light speed catastrophically collided and merged in a brief cataclysmic storm of writhing and twisting space-time that brought the waves to crescendo.
The climaxing gravity waves from this catastrophic collision surged out of their birthing galaxy and into interstellar space. Spreading across our universe for nearly 1 billion years, they stretched and they squeezed all that they met, stars and planets and nebula, in patterns that encoded a portrait of their birth, colliding holes and space-time storm. Then, 50,000 years ago, when humans shared Earth with Neanderthals, the spreading and weakening gravity waves sailed into our spiral-armed Milky Way, our galaxy, our home.
On September 14th of 2015, near the Antarctic peninsular tip, the waves, flying upward, plunged into the earth through air and then oceans, then rock, whispering up through Earth's bowels unscathed, and emerging just north of New Orleans, the gravity waves came face to face with a complex and huge L-shaped invention designed and built to perceive them. LIGO, the Laser Interferometer Gravity Wave Observatory. Flowing through LIGO, the gravity waves stretched and then squeezed microscopically two very long beams of bouncing light that extracted the portraits the waves had encoded, colliding holes and space-time storm.
This tiny shutter in LIGO was momentous for the whole human race, our very first moment of contact with the warp side of our universe. The warp side of our universe is home to many beasts that are forged from warp space and time, beasts that may well include black holes, wormholes, time machines, and cosmic strings, gravity waves and singularities, our Earth's Big Bang birth, and many other beasts, wondrous, weird, and wild.
For decades I, a beast, materially composed, have been consumed by quests to fully comprehend this warp side of our universe. How? Through tricks of mathematics and computer simulations, probing Albert Einstein's relativity equations, and in a 1,000-person fleet of scientists and engineers, we've pursued a quest to invent, construct, and utilize our behemoth LIGO for humans' first encounters with the warp side of our universe.
Big questions have driven these warp side quests, some that I'm sure you have asked yourself, and some you likely have not. How did our universe begin? Can anything travel backwards in time? Can advanced civilizations build wormholes for fast interstellar travel? How does warp space-time behave when wildly, frenziedly writhing like the open sea in a storm? How does the warp side of our universe impact the material side, the side that we humans see and feel?
In this artistic, poetic book that will undulate in your hands, Lia and I use paintings and verse to shed some glimmers of light on all of these big questions. And so that is the prologue to the book. And we just want to pause and to give you some flavor, a bit of the rest of our book. We'll play for you some of my verse and animations of some of Lia's paintings that together explain succinctly what is a black hole. What is Felicia? She's the sum of all her parts. Her face, her silken hair, her arms and breasts, her hands and legs and feet, her heart, her brain, her precious personality. And what is a black hole? It's the sum of all its parts. It's space that is warped, the funnel of bulk being seas, its vortices of whirling space, its tendencies that stretch and squeeze, its slowing time and down cascading time, its horizon and its singularities, all made from warped space-time.
Thank you very much.
So pretend like you don't see the AV guys right now, whisking everything away. This is such a treat for me to be here with two of my favorite people. I'm with this award-winning artist, this Nobel Prize-winning physicist, so I thought I'd keep it really highbrow and start with Playboy. So can you tell me the story of Playboy?
Isn't that how all books begin?
So in 2010, Playboy invited you, Kip, to write an article, or was it both of you at first?
So Amy Grace Lloyd, who had been the editor at Norton on my book, Black Holes and Time Warps, a wonderful woman, a wonderful editor. She had been brought to Playboy magazine as literary editor to try to distinguish Playboy from other gentlemen's magazines through having literature and science and interviews of a highbrow sort. And so she invited me to write an article about warped space-time.
People read it for the articles.
Pardon?
Yeah, people read Playboy for the articles.
Yes. And so I said, well, I would love to do it, but if Lia would do the paintings for it. And so she and the art editor at Playboy looked at Lia's paintings, and they were very enthusiastic. And so we were off and running. We wrote over a period of a few months an article of, I don't remember, 4,000 words or so, and 5-6 paintings. And we were very proud of it. And we submitted it to Playboy. And maybe you could explain.
Yeah, you want to pick this part of the story up, Lia?
So the article goes in, and it goes directly to Hugh Hefner, and we get an email that Hugh Hefner has personally rejected my paintings because they did not live up to the objectification standards of women in Playboy, which I still take as such a badge of honor.
Now, I'd be showing those paintings, but we can't find my clicker. But that's what we love about this place. So is my clicker on the ground? Oh, it fell down with the microphone. Thank you, thank you. And so here is an example of one of those paintings in our beloved Felicia, who is hiding out there. And then you decided to keep going with this article anyway. So how did this, actually, first I really want to ask you about your friendship, because this is not a professional collaboration, quote unquote. This is a collaboration out of love and friendship. How did you two meet? Lia, you want to tell me how you both met?
Yeah, well, I like to say that I met Kip many years before Kip met me, and it started with the gift of a book. So many of us in our lives, you're all here on a Thursday night to celebrate a book. And my mother had given me a Kip's book, Black Holes and Time Warps, Einstein's Outrageous Legacy.
The one that Amy Grace Lloyd had edited.
That's right. And at that time, I was in graduate school for painting, and it was the beginning of me starting to think about using science as the entry point of a subject matter in my artwork. And there was something, I had taken a lot of astronomy classes. I, at one point, thought I would double major in astrophysics when I was in college. So I knew the subject, I was already passionate about it, but reading this book, Kip transported me. I felt like the ideas of black holes or traveling close to the speed of light were embodied. And it was the first time where I thought, oh, this could be an experience of these things. So one of my paintings in my MFA show at Yale was a 5-foot by 16-foot painting of a wormhole. It was really inspired by the way that Kip wrote about wormholes. And then fast forward, I think it was like 6 or 7 years.
Yeah. So Lisa Randall, who's here in the audience, professor of theoretical physics at Harvard, Lisa had been at Caltech on sabbatical, and she threw a party for friends at the end of her sabbatical. She's on sabbatical now again. It seems to me she's always on sabbatical.
I used to make fun of Lisa for her sabbaticals. I'm glad you said it and not me. I'd be in real trouble.
She and I had an interesting conversation about that. It's called a selection effect for astronomers. Anyway, Lia invited both of us because she was friends with both of us to our party. And we're at the party, and I heard someone say something Kip Thorne, and my ears immediately perked up. And with absolutely no chill, I ran up to Kip. And I'm pretty sure, I mean, I don't think in the first sentence I said, like, I nearly begged you to come over for a studio visit. Was that intimidating? Well, you did very quickly, and I was intrigued, so I came. And when I got to your studio, I did say to you that I have this young filmmaker who I'm gearing up to work on a film with in Hollywood, and that I would love to have a drawing that depicts black holes and wormholes to show to him, just to give him some sense of what these things are all about. Would you make a drawing for me? So she made this fabulous drawing, which I now have framed sitting in my home office, and which appears in a number of my publications because I still so love it.
I had never heard of this guy. His name was something Spielberg? Is that what it was? He said a young filmmaker.
Yeah. And he was the director of this film in the early creative phase.
This film being Interstellar.
This film being Interstellar.
And you wrote the treatment for Interstellar.
I'd written the treatment that from which the movie sprang, together with Linda Obst, my Hollywood partner. And so anyway, I showed it to Stephen, and it was really a powerful way to start our collaboration. Just by the by, Stephen carries along more movies in the creative phase than he can possibly make. And when it came time to decide which one he was going to make, Lincoln or Interstellar, he chose Lincoln. And we then, fortunately, got Christopher Nolan to come on board to do Interstellar. But and Stephen's remark to us when Chris came on board was, "You got the right director for this movie." And I think it was true. But anyway, that's the story of yeah.
And even in that instance, we just had, I would say, almost immediate chemistry of loving to talk back and forth. So that was when Kip came to invite me to do the Playboy article. It was actually really hard to even keep the article to 5 to 6 paintings and 4,000 words, because every time we'd get together, I would say, it could be like this, it could be like this. So it was already almost not contained.
So once Hugh Hefner rejected it, we agreed instantaneously, let's turn it into a little book.
Which we've been calling for 10 years, a little book.
And
It weighs
At
like 4 pounds.
260 pages.
finally, Bob Weil, our wonderful editor at Live Right, which is a imprint of Norton Publishers, finally he said to us, listen, this is not a little book. You've got to quit using that phrase. And so.
Now, I notice in both of you an experimentalist tendency. And, you know, Kip, of course, you're a theoretical physicist, but you're a master thought experimentalist.
I'm also good at talking to real experimenters.
Yes, indeed. And I want to reference that when you first started at Princeton as a young student, you studied with the legendary John Wheeler, who's the granddaddy of American relativity. And at that time, the concept of black holes was still contentious. It was still under debate. And I believe you made a famous bet with your friend Stephen Hawking about the existence of black holes.
Yes, so Stephen Hawking and I became very close friends quite early on. And in an era when Stephen was starting to do his greatest work on black holes and their properties and the laws that control black holes. And so we made him, and this was at the time when the first observations of the possible candidate for being a black hole were made, something called Cygnus X Run, from which X-rays were coming. And so Stephen and I made a bet that over whether or not there is a black hole in the source of the X-rays for Cygnus X1.
And I remember, I believe you telling me, I don't know if this is right, did Stephen break into your office when he decided to call the bet at Caltech?
So
I think you told me this.
We made the bet back around 1972 or 73. And in 1990, I was in Moscow with my wife, Carol Lee, and he came to Los Angeles, invited by the University of Southern California, and so he went over. I mean, he was a constant visitor at Caltech. He happened to be at USC at the time, and so he came over and found some of my students who helped him break into my office, and he thumbprinted off and conceded this. But
What's the bet mounted on your wall?
It did take nearly 20 years until he was ready to concede that this really was a black hole.
Now, Lia, you grew up in a world in which black holes were sort of an accepted phenomenon. And how does this influence you, this idea of integrating science into your work? I know that you also bring your students to Mount Wilson Observatory, which is related or near Caltech. And this has really been in the fiber of your work. I'm just very curious what it's like when you live in a world where you know these things have been observed and discovered.
I mean, I think for me, science was always integrated in just being a curious, creative person. My father is a scientist, and my first job was at a science museum doing cow eye dissections. Pretty weird for a 15-year-old kid. But I just always felt that art and science were always pushing up against one another. So this isn't like taking two disparate things and trying to find some commonality. It just kind of seems very integrated. And you know, even when I was studying astronomy in school, I never wanted to be an astronomer. I just loved the way it excited me and fascinated me thinking about what could be. And even just going out into the garden tonight and looking through Saturn, I've looked at Saturn a million times. I have a small telescope myself, and every time it's so exciting, the experience of the universe that could be transmitted to you. So the opportunity to work with Kip to take some of these really cutting-edge concepts, and I hope you'll find in the book that Kip is actually bringing in things that are not known about black hole tendencies and vortices. This is really cutting-edge science. And to try to visualize or bring to a wide audience this excitement and passion about these things.
Now, also the layout in Lia's work influenced how you wrote the book. You both describe it very much. You weren't working on two separate sides. You didn't write a manuscript and then Lia made work. It went back and forth and back and forth, and then when you started to see it, you changed from prose to something more poetic.
So very early on, as we were working on this little book, a friend of Lia's laid out this little book in a first layout, and on a pair of opposing pages, she broke my prose, which I had polished, as I generally do, so it flowed really nicely. She broke it up into lines that were sort of like stanzas and placed them next to the paintings. And I looked at that, and I had an epiphany, the kind of epiphany I would have maybe once every two or 3 years, a great discovery. This one was not about science. It was about me and this book, that I could turn this prose into verse, and that would make the book feel completely different from when it was prose with illustrations. If we turn it into verse that is tightly integrated with the paintings, then we would have something quite different than anything I had ever seen before or written before about science. And this evolved very quickly with then my writing verse, struggling to write verse, Lia making paintings, and us feeding back and forth, feeding off of each other's work. And it grew into something that is so different from things I've done before. I came to realize that this combination of the paintings and the verse tightly integrated was ideal for conveying the essence of the subject of the warp side of the universe, not the fine details like I would normally do in black holes and time warps and other kind of normal scientific writing, but the essence, the feeling, the essential concepts, and relating it to us as human beings in a manner that I had never attempted to do before. I realized that it was possible.
I also think it was so open-ended because we were really making it for ourselves. The ongoing 10-year joke was, we're making a book for the two of us. Like, this is our dream book, that it would have this like very open invitation. It would be sensual. It would have poetry, all these paintings. But who else would want a book like this?
We'd never find a publisher for it. And,
exactly.
But it was such a joy that's what mattered.
So in a weird way, it's like an extension of our conversations. It's not that Kip would come over with verse or send it in a way and say, okay, there need to be paintings about this. A lot of the chapters are just conversations we'd have, and he'd come over, we'd talk, and then a week later I'd say, hey, I made these paintings.
Tell them about Lia's time machine story.
Oh yeah, Kip came over and told a really mind-bending story about time travel. And in an attempt to sort of figure it out, I told him back a story that I thought could explain what he was originally saying to me, which quite frankly made my head feel hot. And so he then took my story back to him, and there's a sub-chapter in the book called Lia's Time Machine Story, where I'm passing books to my wife Felicia through a wormhole.
And creating a pile of books that's so heavy that it destroys the wormhole.
So to talk about wormholes, I'm reminded, and correct me if this is right, you got a phone call from Carl Sagan when he was working on his treatment of his film, Contact, and it got you thinking about wormholes. You essentially invented then the mathematical concept.
Yeah, well, no, the mathematical concept really goes fundamentally to Albert Einstein and Nathan Rosen in the 1930s, and then picked up by John Wheeler in the 1950s, and he coined the phrase wormhole. But what happened was that Carl Sagan had his heroine traveling through a black hole to get to the vicinity of the star Vega, and he sent me this was a novel originally, and he sent me the novel. It was in page-proof form, and he said, I'd like you to help me. I know I'm probably in trouble here. And so I responded, yeah, you're in trouble.
Because she was going through a black hole, right?
You better not go through a black hole. Let's go through a wormhole. He says, what's a wormhole? And that was when I, for myself, first asked the question, can you hold a wormhole open? Because John Wheeler, my thesis advisor, together with a plasma physicist named Martin Kruskal, had discovered that wormholes, if you leave them to their own devices, and if they are not carefully threaded by something to hold that repels gravitationally, they collapse, and you can't travel through them.
So this is a story you're telling Lia,
So this
and,
is- yeah.
and the instability. You also figured out a way to kind of make them time machines.
Yeah. And so anyway, I fed this to Carl and how to hold the wormhole open possibly, and this leads ultimately to this. So there's a lot of backstory here, but yeah, you can read the details of the backstory in Black Holes and Time Warps, but you can read the essence of what's going on with wormholes and with the self-destruction of wormholes and with holding the wormholes open. And how do you hold wormholes open? By the use of carefully crafted vacuum fluctuations, and you don't have any idea what a vacuum fluctuation is. And so I said to Lia, would you please draw a painting of vacuum fluctuations?
And I was like, what are you talking about? What does that look like? And Kip says, well, you'll show me.
So vacuum fluctuations are not things that we as physicists normally look at. And so it was a question of her devising a way to get the essence of this concept across. Yeah, I realize vacuum fluctuations are gobbledygook to you, but once you've looked at Lia's paintings, maybe they won't be anymore.
Lia, can you tell us a little bit about your process? Because what we see is not how they're made. Can you describe to us a little bit the process, the scale, what you go through to render them as we see them, as we discover them in the book?
Yeah, all the paintings are quite small. This is a real departure for me. I like to work really large. But for this project, it was really important that I was able to make quick iterations with Kip. They're all done ink on a Duralar paper, so it has this really fluid, sensual sensibility because the ink is not soaking into the paper. It evaporates up. And I love that it has, like Kip has pointed out, that there's an essence of gravity that's moving the ink around and sort of making what I'm trying to do difficult to work with.
When it pools and has not yet dried, if she just slants the paper a little bit, it'll start to run and drip. And she uses that to, on occasion, to fine-tune the paintings. So
Kip's gonna
gravity is
start
coming
doing
in
my
play.
artist lectures from now on. I think I love hearing you describe my process. But I think
Yeah,
one of the,
and you're so patient with me.
you guys want to see me try to explain Kip's science, and then Kip, it's like the second portion
It's
of
like
this
a comedy
talk.
routine.
It's like
Vaudeville.
everyone get drinks, and then we'll come back and do that lecture. But I think the most important part is not just necessarily the ink or the materiality, but that it's very iterative. So what you'll find is the book is 260 pages long. Nearly every background is its own painting, but there's approximately 100 paintings that look like, you know, an object in the book. But to make that, there was 668 paintings made to get to these final pieces. And
That doesn't count the sketches that I gave to you and the markups I gave to you.
Kip Thorne actually has a lot of artwork involved in this book too. He made a lot of, we would draw back and forth. We have a very visual way of communicating, but many of the times, like I would make something, this is a good example. I know that this one has like 10 iterations, and to figure out what something was, we would figure out what it wasn't visually. So it was really important to be able to work really quickly and kind of push things back and forth. Sometimes the language was not verbal. It was just by looking and saying, oh, it's a little, nudging it a little bit back and forth. And I think that was a really unique way of creating a book, because it's almost like the book told us what it needed. We never set out to make a 260-page book. It just sort of kind of ended up there. Yeah.
Grew organically.
Okay, great. Now, during this time, it's 13-year collaboration.
13 years.
And
This
during
is very short for Kip's
Right,
collaborations, by the way.
Right, let's talk about a very long collaboration, which was, you mentioned LIGO in your prologue. where you were working on the campaign where, as you said, you're very good at speaking to experimentalists. And you were speaking in particular to Ray Weiss, who won the Nobel Prize with you for that project. It was a 50-year endeavor, and during these 13 years, you're still working on this.
Yeah, it came to fruition while we were working on the book. But the other thing that came to fruition was computer simulations to show what really happens when two black holes collide.
Explain to us what the project is about, so people understand gravitational waves.
Okay. So it seemed likely to me many years before we discovered gravitational waves, the first thing we would see would be two colliding black
You're
holes.
the only one who said that to me, by the way. I don't mean to interrupt you. How dare I interrupt you? But everybody I asked before the discovery said, no way, black holes. You were the only one. You looked me square in the eye. You're like, it'll be black holes first.
Yeah, well, I was convinced, but I also didn't shout at the sky because I'd been accused of overestimating the strength of the gravitational waves, and I had been a little burned by this. And so I would tell you privately. But I told lots of people privately. But anyway, that's a separate issue. Well, the people I particularly told privately were the people who were doing computer simulations. And I started pushing them in the 1980s. You've got to get these simulations under control for simulations of two black holes colliding so that we know what the signal really looks like when we see a signal, and we will be able to compare with the predictions, which we could not do the predictions by solving Einstein's equations with pencil and paper. We could only do them through computer simulations. And so so when the computer simulations were not going well, and I thought we were within a decade or so of seeing the gravitational waves, I grabbed the bull by the horns and started a research program at Caltech to do these simulations.
What are you simulating?
Well, you're simulating two black holes that are orbiting around each other. And I showed you this, an animation of Lia's paintings of this. They go around each other, they spiral together, they crash together, they create a giant splash of distortion of space and a oscillation in the rate of flow of time. And I call that basically a storm in the shape of space and the rate of flow of time, or a storm in space-time. And we did not know until those simulations came to fruition in this Cornell-Caltech collaboration led by Saul Tukolsky at Cornell. We didn't know until those simulations came to fruition around 2012, 2013, just 2 years before we saw the waves. We didn't know what the waves would look like for sure. And so this was also simultaneous with our working on the book. And we were discovering, I together with students and postdocs and colleagues, were discovering the details of how warped space-time behaves in a storm. And that's a big part of this book. So this book really is describing things that were being discovered while the book was being growing organically in our joint hands. Mm-hmm. The computer simulations, the discovery of the details of of warp space-time in a storm, and then the discovery of the gravitational waves, and then the verification through the gravitational wave observations that what the simulations were giving us was really right. And that's all in the book, is a major part of the book. Mm-hmm. And that was really so exciting to be creating this book that has the essence of it with Lia simultaneously with the big discoveries being made.
Can I ask you to go back in is it possible to show a picture of an apple? Because there's this amazing book you all should check out.
Oh, well, you shouldn't. Okay, well, now I'm the cornball actually going back to
There you go. And the book is called...
One of my favorite paintings.
And so the book is called Black Hole Blues by Jana Levin, and it tells you the history of this momentous project of how LIGO came to be. And so there's a little love note to Jana snuck in our book where the apple is on top of her book here.
I have to say, also, Kip, you introduced Lia and I It was
Oh,
at
I
a
did?
party you had.
You guys, go to parties. You'll meet the weirdest physicists.
You had a party for Stephen Hawking at your house, and I met Lia that night, and like the next day ran off through LA, going to crazy museums together. It was immediate. It was a
I
similar
had
thing.
just met Stephen Hawking, and to get introduced to Stephen Hawking, Kip said, "This is the artist that I've been telling you all about." And then about 15 minutes later, I get introduced to Jana, and she said, "I'm an astrophysicist." I was like, "So? I just met Stephen Hawking." But it was also love at first sight.
So this must be incredible for you, Lia. You're working with Kip. This is a 50-year collaboration. I do want to point out that when the discovery happened, it was 2015. On the eve of that discovery, Ray Weiss, with whom you share the Nobel Prize, said, if we don't discover black holes, this whole thing is a failure. And, Ray's a real straight-talking, no-nonsense kind of guy. So everything was at stake. Once again, you're taking huge risks. You don't know if it's going to succeed. I mean, Lia, you're here watching this happen with your friend. You have no idea this discovery is about. None of us have any idea that it's about to happen. What's that experience like for you in this collaboration, to see something like that, even in your own work, that you're working out with Kip in real time?
Well, to make a project that was just sort of going on and on and on, there was a moment where we had something that kind of was concise, and it didn't end with the discovery of gravitational waves, but it kind of led up to it. And then I remember I don't know if you remember this, we were having a phone conversation. I said, should we show this to somebody? And you said, maybe we should wait till January. And I thought, that is the weirdest thing to say. And I was like, oh, I have a feeling
Something happened.
Something happened. And I mean, I think in the announcement, I just felt like so profoundly excited just to bear witness and to be alive at this new frontier of really astronomy and the new revolution of how we're actually going to understand the universe. It is so profound to wrap your head around that we're not going to be looking at the universe, but we're going to be detecting the warping of space and time. I mean, it's just unbelievable.
Let me just add that one of my favorite parts of this book is a description of the different emotional reactions that Ray Weiss had to the discovery, that I had to the discovery, and that the people who really pulled it off in the end, which was the younger generation, a fleet of 1,000, as I say, their reaction, completely different emotional reactions, and I mean that was fun to write and describe, but also emotional for me to write and describe.
Now, I know you've said that when you got the call about the Nobel Prize, 2-something in the morning your time, and it's only a couple of years after the discovery. It's extremely swift. Some people go many decades before seeing the award, and they said, are you surprised? And I believe you said, I'm not surprised, but I'm disappointed.
Precisely, and again, this is in the book. I said, I'm very disappointed because the prize should have gone to the fleet of 1,000 people who really pulled it off, and should not have gone to just 3 of us.
And that is a rule.
It's a rule. I mean, I had extended conversations with members of the Nobel Prize Selection Committee. They have the power to change it. They have not yet chosen to change it. But I believe very strongly that they have an obligation to explain to the people of the world the necessity and power of large collaborations for certain kinds of science, and that the great discoveries are not in all cases made by 3 individuals or some very small number of individuals. In some cases, it is a big collaboration, and this is a beautiful example of it. And we try in the book to really convey the essence of that.
Mm-hmm. And I've heard people argue that perhaps something like the Nobel Peace Prize should go to big scientific collaborations because they represent a transcendence across cultures and communities. And it really seems to me that for both of you, friendship is very important in your creative work. Would you say that's true, Lia?
I mean, I think the real foundation of this collaboration is that we just love being around each other, and what a fantastic excuse to see each other every 2 weeks for the past 13 years.
Now, Lia, you grew up in California. You were like the only girl in your skate punk crowd, right? And Kip, you came from a Mormon family. I believe you said when your mother passed away, there was an article in the local paper that said, "Old radical dies." And
Gigantic headlines, largest headlines I ever saw in that newspaper.
and so you both come from extremely different backgrounds. Lia, what do you think the foundation of this is the creative impulse? Or is it hard to put your finger on? It's just a magic you don't know how to identify.
I mean, one of the things that's been fun for us to think about is why we were so drawn and excited to make this. And we've realized that both of our origin stories come from our childhood and someone or some experience intersecting us at the right moment. And for me, that was both of my parents just encouraging, without any breaks, a kind of love of creativity and curiosity. I mean, my father is a scientist, and I mean, we would just ask questions about everything, just anything and everything. We would just explore the world, and I just felt like I could, that the world was right at my fingertips. And that was really the biggest gift that anyone could have given me. So I never felt scared of science. And I think that that's one of the things that we really wanted to do with this book, is to make science accessible as an open invitation to maybe a point where there's a cutoff, where someone all of a sudden feels like, oh, I don't know that. I can't figure out the math, so then I can't understand these things. I might be interested, but I'm not going to really get it. And this is why we wanted to make a book that was not didactic, that, just like Kip said, really captures the ethos and the essence of the universe.
Mm-hmm. And Kip, you've never stopped marveling. I mean, you hear it in your words. Every word feels as though for the first time you've thought about the wormhole, or Lia's retelling of the time warping story suddenly invokes in you a complete, genuine sense of wonder.
Yeah, the universe is a marvelous place with huge surprises, and some that I simply could not believe when they first came to us, and still don't understand how the universe can behave in that awful way. But usually it's not so awful. Anyway, that's a separate story. But yeah, I think the key thing was that I did fall in love very early, at age 13, reading a book by George Gamow, a cosmologist, titled 1, 2, 3, Infinity, where he described how the laws of physics control the universe, control its structure, control how it evolves. And this was just so mind-blowing to me that I wanted to understand how that could possibly be. And I decided I would spend my life trying to understand that, and so here I am. And it is as wondrous to me today as it was at age 13.
I think I've also heard you say that you're very happy just sitting on a hill looking out, quietly contemplating.
I prefer to sit quietly and think, but my best inspirations come when I'm half asleep at night. But they are building on the things I was struggling with in isolation, trying to calculate or just puzzle things through when I'm awake.
You've worked on such incredibly risky things. When you first started, you didn't know if black holes were real. Certainly gravitational waves were incredibly hotly debated, back and forth. Many people opposed to your project, thought that it should not be refunded even, and you continue to take risks. What is your sort of attitude towards risk-taking? People are very afraid of that.
Well, I think I had the advantage that I got more positive strokes, praise, than I deserved when I was early in my career. And so that made it easier to take risks. The fact that I was well known in my field and became well known very early, and somehow I could take risks and not pay a price for it like some other people did. And I was just lucky in that way.
And Lia, do you feel you're taking big risks by doing things like this? This is not typical, contemporary art speak and a contemporary way of going about things?
I mean, I think that I just continue want to excite myself and stay curious in my studio. So I love learning new things. So I'm not someone who continually makes things that are like the same thing again and again. I make kind of a series and then I move on, and I use that as an opportunity to learn something new. So this was just an extension of that. That was another, I never thought of this as a risk, but I love this unknown spot in my studio where I'm fascinated by a concept. I know I want to make something about it, but I just have no idea what it will actually turn out to be.
What do you think is next for you, Lia, work-wise? Don't look at Kip.
Well, we had a great conversation with someone who helped us make the book, and she was saying that this is on the night the book comes out, and she said, you know, you got to talk to Kip because this really should be a kid's book. And I said, Charlotte, it's been 13 years. The book comes out tomorrow. Just give us like 24 hours. And then I was on the plane with Kip the next day, and I said, you know, that's kind of a good idea, like black holes for 5-year-olds.
So, yeah, you have to understand that Lia has a 2-year-old and a 4-year-old, and wonderful children. And so she's all hot to create a book like this for them.
If it takes you that long, they'll be in their 20s by the time you're done.
Exactly. And it's like, we could make the book, then go back in time and give it to ourselves and be inspired by the book to then
you don't
be
have to write
art.
it. Yeah. You could give it back to yourself so you don't have to write it in the first place. It'd be easy. I just want to ask Kip a final question, which is, what are you dreaming about now? What are the unknowns for you that as you're falling asleep, you're thinking about?
Well, there are things that are the unknowns that I hope before I pass away. And my intention is to live to 110, so I've got another 27 years. I think I did the math right. Anyway.
Just enough time to finish your book.
I hope that the younger generation will definitively find the laws of quantum gravity, and this is all discussed in the book, my dreams and my hopes. They will discover the laws of quantum gravity definitively, and with them simultaneously discover the details of the birth of the universe, how the universe came to be. So for me, that's the holy grail of physics. It's not something that I am pursuing. It's not something I would have ever pursued because it's such a hot topic that I would not have elbow room if I tried to work in it. So I've left it to others like Lisa Randall to pursue these issues. And I've focused on things where there's a lot of elbow room. But I marvel at the efforts that she and colleagues make in this direction, and at the signs that it may actually crack, and we really will, before I pass away, understand the birth of the universe and these laws of quantum gravity that controlled the birth of the universe. So that's one hand. On the other hand, myself, I'm at a phase of my life where I can do anything I want to do, and I just want to do new things. And so this was a new thing for me, a marvelous new thing that sort of fell into my lap unexpectedly. And I'm looking for more like that.
It's a beautiful thought to close on. Thank you so much. You're two of my favorite people. Please join me in thanking Lia and Kip.